What we're going to do today is a review of the first section in Chapter 5, that's Section 5.1, and then move to Chapter 9 and do 9.3, 9.4, 9.5, and we're going to get to that in just a second. So let's start with 5.1, and just as a review, I'm going to do one problem. In 5.1, all I'm expecting of you to know is when you have two equations, two simultaneous equations, how to solve them. So you have two variables and you're solving for the value of those two variables. I'm going to do an application problems. Problem number 18. Problem number 18 on page in your 5th edition book is page 248. It says Kelly Fisher has a total of $30,000 invested in two municipal bonds that have yields of 8% and 10% interest per year, respectively. If the interest Kelly receives from the bonds in a year is $2,640, how much does she have invested in each bond? So from the last statement, you realize that this is trying to find the amount of money invested in each bonds. Let's call them bond A and bond B. So we're going to define our variables. We say X is the amount invested in bond A, and Y the amount invested in bond B. Okay? So when you read the problem, it says that she has $30,000 invested in these two types of bonds. Therefore, you can come up with the first equation. You say, therefore, the amount invested in bond A plus the amount invested in bond B should be equal to $30,000. So that would give you one equation. Then it says, the total money interest that she earns at the end of each year is $2,640. So this $2,640 is the interest earned from both of these. Then you say, how much is she getting out of bond A? Bond A is paying 8%, so it would be 0.08 times X. How much is she getting out of bond B? That's 10% of the amount invested, so it's 0.110 times Y. Therefore, these would be your two equations. Two equations you have to solve simultaneously for X and Y. Okay? The easiest way is to solve for X, for example, in one and plug it into the second equation. So if we solve X from the first one, that means X is equal to 30,000 minus Y. Now, in place of X in the second equation, we're going to put this equivalent. So the second equation now would read 0.08 times X. In place of X, you put 30,000 minus Y. Then you have plus 0.10 Y equals 2,640. Now you basically have an equation in one variable. Let's simplify that. 0.08 times 30,000 is 2400 minus 0.08 times y plus 0.10 times y equal 2640. Then on the left hand side you keep your y, so 0.08 y and 0.1 y would give you 0.02 y equal, you already have 2640. You take the 2400 to the other side, it would be minus 2400. Therefore 0.02y equal 2640 minus 2400 would be 24. I'm sorry. Yeah, it would be 240, right? It would be 240. Then y would be equal to 240 divided by 0.02. That would give you $12,000. That is the amount invested in bond B. That's what y was. Then since the total was 30,000, and we said x plus y is equal to 30,000, so that means x plus 12,000 should equal 30,000. So x is equal to 30,000 minus 12,000, which would give you x equal 18,000. So the amount invested in bond A that pays 8% should be $18,000. The amount invested in bond B, which pays 10%, it should be $12,000. Okay? So that basically take care of a review of section 5.1, which is the only section we cover for this class in this course. Let's move on to chapter 9, which is talking about derivatives. As you know, derivative is talking about the rate of change. That's what the derivative is. We start with section 9.3. We start with section 9.3, which is talking about the rate of change. And it goes and tells you that you have instantaneous rate of change, which is the same as the slope of the tangent line to a curve, and also it is the same as derivative of a function, and that all would be calculated as f of x plus h minus f of x divided by h. You take the limit of this whole thing and drive h toward 0. So this would become the slope of a tangent line, which is also the same as the derivative or the rate of change. To do an example, if you go to the end of chapter 9 in the review section, I think that's where I chose the problem. End of chapter 9 in the review section. And look at problem Well, actually, I chose this from 9.3, section 9.3, problem number 20. Section 9.3, which is on page 583. Again, I emphasize sometimes these numbers would be different. These problem numbers would be different in different edition of the textbook you may have. Edition 4, for example, the numbers might be completely different. You need to find and see which one is we are talking about. This problem says find the slope of a tangent line to the graph of each function at the given point and determine an equation of the tangent line. So first we want to find the slope of a tangent line, and then we want to find the equation of the tangent line. Okay, we just said the slope of a tangent line to any curve would be calculated as f of x plus h minus f of x divided by h, and you take the limit of this and drive h to 0. So if function given to you in problem number 20, f of x, is given as 3x minus x squared, this is your function. And in this section, it talks about the four step you have to take to come up with the slope of a tangent line. The first step is to figure out f of x plus h. In other words, you evaluate this function. You evaluate this function at f of x plus h. So you say f of x plus h is therefore equal to. So every place you see an x, which is here and here, you plug in x plus h. So it would be 3 times x plus h minus x plus h squared. Therefore, it would be equal to 3x plus 3h minus x plus h squared. You expand it, it would be x squared plus 2xh plus h squared. Then therefore it would be 3x plus 3h minus h squared minus 2xh minus h squared. Therefore, that is f of x plus h. Back in the formula, you're going to plug it into this formula, So the slope of a tangent line, well, in the formula, f of x plus h is this whole thing, 3x plus 3h minus h squared minus 2xh minus h squared. That is f of x plus h in this formula right here, minus f of x minus f of x. Well, that's the original function. This is f of x. So it would be minus 3x plus h squared divided by h. Now you can simplify. The plus h squared here and minus h squared would cancel. Minus 3x and plus 3x would cancel. And what remains in the numerator, you have to take, again, you're trying to get the slope of a tangent line. You have to take the limit of what and drive h to 0, what remains between 3h minus 2xh and h squared. Let's factor out h out of there. So it would be 3 minus 2x minus h divided by h. Don't forget that it's divided by h. Now this h and this h would cancel before you take the limit. So now basically you're taking the limit and driving h to 0 of 3 minus 2x minus h. And that would give you the slope of a tangent line. This would give you the slope of a tangent line. Now, when you drive h to 0, towards 0, the only place that would impact is right here. It's a minus h. So that h would get smaller and smaller and smaller until it would disappear. Completely. Therefore, the slope of a tangent line would be 3 minus 2x. That is the slope at any point x. I get to the specific point in just a second. That is for any point. If you read this problem 20, it says find the slope of tangent line at coordinates of minus 2 and minus 10. So that is like x and y, coordinate x and y. So the x here is minus 2. So to find the slope of a tangent line at this specific point, you plug in for x minus 2. So it would be 3 minus 2 times minus 2, which would be 3 plus 4, which would be equal to 7. So the slope of a tangent line to this point would be 7. To find the equation of a tangent line, you use the formula you had before, which is y minus y1 equal m times x minus x1. So the point you have is this point. So this is like x1 again, and this is y1. So y minus 10 equal m, we found it to be 7. X minus x1 is minus 2. So y plus 10 equal 7x, and minus 2 is plus 2. So it would be 7 times 2 would be plus 14. Therefore, y would be equal to 7x plus 14 minus 10. Y therefore is equal to 7x plus 4. This is the equation. The equation of tangent line. Tangent line to the function that is given in exercise 20 at point of minus 2 and minus 10. If you have a graphic calculator, you can graph that, or you can go to coolmath.com and they have an online graphic calculator, or you just Google online graphic calculator. One of the better one is on coolmath.com, and you plug in your original function, and you can check your answer basically and find approximately whether you are correct or not. So that's basically section 9.3, talking about the slope of a tangent line. As I said before, the slope of a tangent line is the same as the concept of derivative. In the next few sections, it talks about how to get the derivative of a function using the basic rules of differentiation. So you don't have to go through these 4 steps, f of x plus h minus f of x divided by h, and take the limit of that. Right? So knowing the rules of differentiation would cut It's like a shortcut for you. So we start with the first rules of differentiation. The first rule says if y is a function of x and that is equal to a constant, let's say a is equal to a constant, then y prime, which is prime means derivative, which is the same as showing it as f prime, would be equal to 0. That's the first rule. So if your function is a constant, derivative of it would be equal to 0. So if y equal 5, that means y prime is equal to 0. Okay? Rule number 2. If your function is y is a function of x and is equal to x to some n power, then y prime or f prime of x, which by the way sometimes you can show it as dy dx, that means derivative of y with respect to x, all of them mean the same thing, all of them means derivative, would be equal to n times x to the power of n minus 1. So y is equal to x to the third. That means y prime would be equal to 3. That is n comes to the front. X, subtract 1 from the power of 3, which would make it 2. That's a derivative. Another rules of differentiation. If y as a function of x equals some a times x to the n power, then y prime or f prime of x would be equal to a, n comes to the front also, x, n minus 1. You subtract 1 from the power. For example, if y is equal to 5, x to the 6th, then this would be 5 times 6 times x, subtract 1 from the 6 would be 5 power. Therefore equal to 30 x to the 5th. That is the derivative. Continuing. If y is a combination of two functions added or subtracted from each other, such as f of x plus or minus g of x, then the derivative y prime would be equal to f prime of x plus or minus g prime of x. So, as an example, y can be, say, 3x to the second minus 5x to the third plus 20x plus 120, for example. So you have more than two individual pieces. So this is one function, this is a function, this is a function, this is a function. So this is like f of x plus g of x plus k of x plus. So for that you have to take the derivative of individual pieces. So y prime would be equal to, first the derivative of this based on the previous rule would be 6x, you subtract 1 from the power would be 1, minus 3 times 5 is 15x to the second. Next, 20x, 1 comes to the front, it would be a plus 20. Sorry. plus 20, and then you would have x to the 0 power, which is, when you subtract 1 from this power, which is h to the 0 power is 1. Therefore, I don't need to write it. And finally, derivative of constant 120 is 0. So this would become the derivative of your function. Derivative of this would be this. If you have two functions multiplying by each other, so y is equal to some f of x multiplied by some g of x, then y prime would be equal to f prime of x times g of x plus g prime of x times f of x, which basically means derivative of the first function multiplied by the second function plus derivative of second function multiplied by the first function. So let's have an example. So y is equal to, let's say the first function is 5x squared plus 2x minus 3 multiplied by g of x multiplied by 2x to the third plus 100. Okay? So if you follow the rule, first to find y prime, first it says f prime of x. F prime of x is referring to derivative of the first function. So derivative of this function, this is your first function, derivative of this would be what? 10x plus 2, close the parenthesis. It says multiply by g of x. G of x is the function, the second function as it is. So multiply by 2x to the third plus 100. Then it says plus derivative of the second function, derivative of this. What's the derivative of this? It is 3 times 2 is 6x squared. Multiply by the first function, multiply by this, 5x squared plus 2x minus 3. That's basically the derivative. You can simplify that by multiplying and write it a little bit simplified form yourself. But that's basically how you find the derivative. So this would become the formula for the derivative when you have two functions multiplying by each other. If you have two functions dividing by each other, so this is another rule. Y is some f of x divided by some g of x. F of x divided by some g of x, two functions divided by each other. Then y prime would be equal to, long division line, f prime of x, that's the derivative of numerator, multiplied by g of x, the denominator, minus g prime of x, that's the derivative of denominator, multiplied by f of x, the numerator as it is, divided by g of x squared. Okay? Let me find some examples of this, and let's see what I have. Let's do problem 40. By the way, I want to do one other one in just a second, but for this particular quotient formula, problem number 40. You just follow the formula. This is problem number 40. Page 654. That's in the review section of chapter 9. it says f of t, a function of t, equals t divided by 2t squared plus 1. Therefore, to find the derivative, which is f prime of t, we follow this rule up here. We follow this rule. It says f prime of t first. That's the derivative of the numerator. What's the derivative of t? That is 1. Multiply by g of x. Multiply by the denominator. That is 2t squared plus 1. Minus, according to the formula, g prime of t. That's the derivative of denominator. What's the derivative of this denominator? That is 4t. Multiply by f of x. F of x is the numerator, which is t. Divided by denominator squared. That is 2t squared plus 1 squared. Let me just simplify this a little bit. F prime of t, therefore, equals 1 times this would be 2t squared plus 1 minus 4t times t would be 4t squared divided by 2t squared plus 1 squared. You normally don't do anything with the denominator and leave it alone. Okay, so the numerator, therefore, 2t squared minus 4t squared is minus 2t squared and plus 1 divided by 2t squared plus 1 squared. That's the answer. Okay. I said I would do another problem from this section, which is a little bit different. So let me do this one also. This is again in the review section, problem number 34, page 654. It says g of x equals 2s squared minus 4 divided by s plus 2 divided by square root of s. Okay, now this looks a little bit different, but we can still do this. I'm going to rewrite this function a little bit differently. So g of x, the 2s squared, I'm going to keep it. Since in the second part, 4 divided by s in the denominator, if I bring it up and put it next to the 4, I have to give make the power negative. The power here is 1, so it would be minus 4s to the minus 1 power. Plus, in the last one, square root of s is basically s to the 1/2 power. Instead of square root of s, I can say s to the 1/2 power. When I bring it up, it would become s to the minus 1/2 power. So it would become 2s to the minus 1/2 power. Now we can use the first 2 or 3 rules of differentiation that we talked about and take the derivative of each piece and add and subtract from each other. So g prime of x therefore becomes, first, the derivative of this first one would be 4s. Derivative of the second one, this minus 1, which is the power, will come and multiply by minus 4, so it would become plus 4. Then the s. Now subtract 1 from this power, so it would be minus 1 minus 1. So that would make it a minus 2. On the last part, this minus 1/2 would come and multiply by 2. That would make it minus 1. Then S, subtract 1 from this power of minus 1/2, it would make it minus 3/2. Okay? A lot of times it will tell you you should not write it when you're simplifying a function. You should not write it with the negative power, negative exponent. So we deal with that by putting it in the denominator. So g prime of x therefore would be equal to 4s, and here would be plus 4 divided by s squared. I take care of the negative there, and here would be minus 1 divided by, instead of s to the minus 3/2, it would be square root of, because it's a 3/2, it would be a square root of s to the 3rd. One more time, we can simplify the last term. G prime of h is equal to 4s plus 4 divided by s squared minus 1 divided by half of a square root of s to the 3rd. S square of it would come out and become s, and what you have under the square root, it would be s also. So that would be the derivative of that function.